Say that I have been given this triangle ABC, and the problem we are going to explore in this video is I want to be able to draw a circle passing through these points A, B and C. So in other words, people also might call it circumscribing. Circumscribing a circle on the triangle or around the triangle. So let me do it with the tool I have first. So finally I want to be able to draw the circle just by knowing its center and the radius, and I'd construct it with my compass. But let me see, just to get an intuition of what it might look like, let me draw a circle with the tool I already have. So this might get a little messy, so I'll adjust it. So let me lock it to form a circle, and let me position this to form 2, so that this passes through A and B now, and now I can adjust it. Okay, now it's passing through all the corners. So let us see, the center is kind of around here. So what will allow me to measure the radius of the circle? So this might be one of the possible radiuses or radii. This might be one of the candidates. Even this would form a radius. So maybe we could try figuring out what OA might be. And to do that, because we know now a certain theorem, a certain result, that if I drop a perpendicular from the center, so this looks, let me draw a straighter line. If I drop this perpendicular from the center to the chord AB, because AB is a chord now, well, I know that it will bisect the chord into 2 equal halves. I have seen this, we have done this, and at Maths Decoded, you may go and check out the videos. So if I do the same thing with, say, let me get rid of this. So if I do it with AC, the chord AC, so if I drop a perpendicular from the point O to my AC, if as long as this is a perpendicular line, as long as OD is perpendicular, it will bisect the chord AC into 2 equal halves. As long as OE is perpendicular, this would be bisected. So maybe I can use this rule to figure out what OA might be. So if I have OA connected and I have OB connected, so I know that AE is equal to EB, because those are just equal halves of the bisected chord. I know that OE is a common side, and I know that this 90 degree is common to both of these angles. So triangle AOE should be congruent to triangle, so I should be careful with the order, it will be BOE, which means that so there's no surprises here, because AO is equal to OB, and this can also be a possible way of for me to find AO, because what I can do is, say that I just have a triangle. Let me pick this scalene triangle, a general triangle. So say that I have this triangle, and I construct a perpendicular bisector of this side, so side AB. Now I am starting with a fresh triangle. If I am able to find the center, then I am done. So say that I construct a perpendicular bisector, because I know that this was bisected by the chord, the line OE. So if I construct a perpendicular bisector, then that would be passing exactly midway between AB, and that would be perpendicular to AB. And if I also consider the perpendicular bisector of the chord AC, which is going to be a chord soon, so if I extend this line, say, and I draw a perpendicular to AC which bisects them, which bisects AC, then the meeting point of those should technically be my center of the circle, and that's what happens right here also. So if now this is the center, I can keep the needle of my compass at O. I'll call this O, and I'll keep the tip of my pencil on A. And since OA is equal to OB is equal to OC by the same logic, I know that the circle has to pass through all the 3 corners. So you should really get your compass out and try and reason through this logic. This is kind of an intuition for why you draw perpendicular bisectors to find the center of the circumcircle. So this circle is called the circumcircle.